good morning. 1 week faculty development program on 3D printing and design organized by Bharatiya Vidya Bhavan, Sardar Patel College of Engineering and sponsored by All India Council for Technical Education's Training and Learning Academy. With all due honors, I would like to introduce you to our today's eminent speaker for this session, Dr. Yenyam Ravi Kumar Sir. Dr. Ravi Kumar Sir is an associate professor in Mechanical Engineering Department at National Institute of Technology, NIT Warangal. He obtained BTech degree in Mechanical Engineering from JNTU, Kakinada in 2000, Masters of Engineering in Computer Integrated Manufacturing CIM from PSG College of Technology, Coimbatore in the year 2002. He has completed his PhD in Mechanical Engineering from Osmania University, Hyderabad in the year 2011 and postdoctoral research in 3D printing at Milwaukee School of Engineering, USA in the year 2012. He has supervised more than 30 MTech projects and produced 4 PhDs and guiding 4 more PhD theses. He has published more than 60 research papers in national and international conferences and journals. He has filed 1 international patent and 2 Indian patents in the area of 3D printing. He is instrumental in setting up rapid prototypic laboratory at NIT Warangal. He started MTech program in additive manufacturing in collaboration with Central Manufacturing Technology Institute CMTI Bangalore, first time in India of its kind. He has established a world-class metal 3D printing facility at NIT Warangal under TechWhip 3 grant. He has conducted more than 15 training programs across India and trained around 900 participants in the area of 3D printing. Today, Sir will be elaborating the topic of 3D printing in complex oral and maxillofacial surgeries. Now I would request Dr. Ravi Kumar Sir to kindly commence the session.
Yeah, a very good morning, one and all. First of all, let me thank the organizers given me this opportunity to address the gathering here, and especially Professor Kiran, who has given me this opportunity to talk before you. And this is my second lecture. Previously, we discussed the design for additive manufacturing concepts in the previous session, and this session is totally different. It is application oriented, and that too it is our experience with the oral maxillofacial or in medical doctors or the surgeons, especially how this 3D printing technology or additive manufacturing. So in the previous session also, we have emphasized on the importance of 3D printing or additive manufacturing. So as we understood from the previous discussions also, wherever you have a complexity in the product, so the 3D printing will shine. And of course, the human anatomy is more inorganic in nature. Of course, it is very complex, especially if you see the neurovascularity in the human anatomy. So it is so complex. And we have another driving force of this technology, apart from complexity, is customization and personalization. Of course, the healthcare industry, where we need to customize, personalize several devices, several implants, several prosthetics. That is as for the patient requirement. Why? Because each human being is unique in his anatomy. And if you take the same person, so if you put up age, so your bone structure, surgical treatments, either in terms of planning the surgery or rehearsal the surgery or design and fabricating the customized implants or prosthetics, that's what I'm going to discuss during this session. And I have organized in this way. So predominantly, I'm going to discuss the individual cases that we have, which we have been, of course. Sometimes it is difficult to pronounce. Why? Because as we know that majority of these terms are derived from either Greek or Latin, then bit difficult to pronounce. But the idea here is, say, cranioplasty is a cranial bone, which it is going to say, if you take the head or the skull part, so you can divide the skull into say three bone regions. Maybe starts with the lower jaw, that is called mandible, and you have the upper jaw called maxilla. And anything other than these two dental jaws, lower jaw and upper jaw, and especially the bone which covers the brain part, then you call that as a cranial bone. So the cranial bone, the implantation, the first case, and then dental placement of the implant for the second case, how these models are helpful, and reconstructive surgery in the third case, that is mandibular distraction osteogenesis. This is one of the surgical treatments in the recent times. So how you can make use of the bone growth um, in combination with a device called a distractor, how you can guide the bone growth as for the patient condition. So, and then how the 3D printing is, say, helpful in that surgery. So that is the third case. And fourth case, there is a one cancer patient who needs replacement of the again a lower jaw. In this case also, uh, the cancerous bone should be removed and kept with implant or augmented with an implant. So how we can um, design and fabricate a customized implant for that case. And even TMJ, or the temporomandibular joint ankylosis, that is the fifth case I'm going to discuss. So this is the joint where your lower jaw and upper jaw, that is the mandible and maxilla, will form a joint. That joint is called as the TMJ, that is temporomandibular joint ankylosis. Then how this technology, in combination with the medical image processing tools, then how we could be able to, say, um, design and fabricate that joint, and replacing during surgery that joint, right? So that is the fifth case. And we have filed a patent also in that, from that case. So, and then the sixth case is like bacilla osseointegrated implant. So this is an accident case. Again, the standard implants that are available from the market is no way it is serving the purpose of the sixth case. So that's what we indigenously designed, an implant that is specific to the patient, say, the requirement. So that is the sixth case. And of course, if you see the future of this technology, now itself, the argon printing or the bioprinting has been, say, promising in the recent times in terms of, say, printing organs like kidneys or like heart or liver or lungs. In the recent times, the most demanded organ is lungs, as we know that for a respiratory syndrome, that is your COVID 19 situation, where most demanded and ever demanded organ is a heart. Uh, then we'll see the state of art of this organ printing. So yeah, that's what I have planned for this session. Maybe next 1 hour 45 minutes we are going to discuss on this. So with this outline, so let me go to the topic. That is, first we start with an introduction to medical 3D printing. How do you get interface your medical diagnostic data with the 3D printing? That's the thing where we need to say start our journey in the medical 3D printing journey. Um, so that's what which we are going to introduce the medical 3D printing practice or the medical 3D printing integration. How you can integrate these two technologies. That's a 3D printing with medicine. How you can. So anyway, probably um, in the last class also I can find some questions from what is the difference between rapid prototyping, additive manufacturing, 3D printing. So, but all are same. The essence of this technology is same. Like as we know that rapid prototyping was the name. It was the former name of this technology called rapid prototyping. That is late 70s and the early 80s where this technology has evolved. Um, and it has been say transformed into a manufacturing say methodology. That's what additive manufacturing, it has been evolved, and the common terminology is 3D printing. So anyway, so whatever this you call this technology, so the essence is same. Like either you start with the CAD model, or either you start with the reverse engineered or 3D digitized data. That's going to be the start point of this journey. Or if you come to a medical domain, so it should a CT, MRI, or any modality that you come across, a digital interface or digital mm, medical diagnostic system where you can get some digital data in terms of images, maybe DICOM form, maybe that is a predominant neutral format that you come across in any the medical diagnostic systems where it will which you can easily save your images into a DICOM format. So that's going to be the start point of this medical application language. So anyway, all our digital inputs, maybe CAD, maybe digitized data, or even it can be a medical scan data, a medical diagnostic data. That's going to be the start point of this technology or the input for this technology, and where you are going to replicate your anatomy, how it has been scanned and it's getting physically realized by stacking those layers into a three-dimensional model, the biomodel that will assist the surgeons to perform any complex surgeries. So the complexities are free of cost in additive manufacturing. That is the mantra or the driving force of 3D printing is complexity is free of cost. Of course, where we need to um, your surgeon oftenly come across several times with the complexity in the surgical treatment. So then it will break that complexity into more simplified, either in terms of a medical domain or in terms of engineering application, automobile, aerospace, or whatever it is. Like wherever you find some complexity in the system, so it will always there, and it will say make the thing simplified for fabrication. So your complexity, of course, and customization, as we these are the two things which your 3D printing, especially in medicine, is going to play a vital role, right? So anyway, then if you see the applications of this 3D printing technology, where you can see the this is a whole statistics. The consumer and health goes 20.8% share, and motor vehicle, that is automobile and automotive together, 18.6%. And if you see the medical dental together, it is 16.4%. It is motor vehicle, that is automobile industry. So then one can know the importance. We should not ignore the medical application of 3D printing. I knew an aerospace, and that's 10.2 industrial business machines, 13.4 academic institutions. Nowadays, it's gaining a lot of attention from the academic institutions. That the 3D printing technology has been integrated a part of the curriculums. That again in the under NEP, that is new education policy, where the AICT is giving a lot of uh, flexibility to introduce a thrust area. In the thrust area, you can start your UG or your UG course especially. So then, which we can have maybe you can have a lot of demand for the upcoming years. But in India, bit we are lagging. If you compare with the European countries or the US or any other places, where still we are not up to the mark to adopting this technology in academic institutions or for this sort of educational institutions adapting this technology is not that much great. But anyway, so we can even see the government, military applications, architecture, and other applications also. This is the a sort of say share the application share the industry wise. And if you see the hype cycle or the Gartner cycle, that is expectations versus time. So you try to place all these applications to this curve, so where you have the technology triggered to the plateau of productivity, where you have a different phases of this, and you try to place all these applications onto this curve. So of course, the early application is prototyping. So the prototyping application, so it is almost touching to the productivity stage. So where the industry is adopting a lot at the application part of prototyping, and even followed by non-critical aerospace applications, and followed by orthopedic applications. So the orthopedicians or the early users of this technology, as far as medicine is concerned, why? Because maybe replacement of bones or the forces that, or in terms of implant or in terms of prosthetics, which people have been using this technology, especially the orthopedicians, and followed by jewelry applications. In India, the biggest users of this technology is none other than jewelry industry. A lot of customization is involved in jewelry, and a lot of um, complexity is also involved in the jewelry design. So where jewelry is also and almost it is in a matured stage, rather than which you can put it in that way. And home are the domestic applications, and dental. Coming to the another application of this medical space is dental. This is almost like the most hype phase, most expected technology or adoption from the dental side. And you have a critical aerospace applications is followed by the critical aerospace applications, architectural applications, sports applications, followed by education and bioprinting. Bioprinting or organ printing is coming. This is very too early, or the technology got triggered. That is bioprinting or medical research and clothing, that is 3D printed clothes, construction, that's also 3D printed houses or 3D printed bridges or 3D printed structures, that is coming in a big way, but that is too early, or this technology got triggered. That's very initial stage. Still, it should take a long time to come to the productivity stage. But maybe over the period of 10 years, 15 years, uh, maybe we can expect these things will be moving towards the plateau of productivity. Even military electronics, so you can